Okay, my friends, so we are talking about, or we have been talking about angles in standard position in our unit circle. Okay? Now what we're going to do is combine what we know about trigonometry, specifically sine, cosine, and tan. We're going to combine it with our unit circle that lives in a positive x, positive y quadrant, positive y, negative x quadrant, negative x, negative y quadrant, and negative y, positive x quadrant. 1, 2, 3, 4. Now, we have been dealing with concepts of angles in standard position, and we've also been talking about the reference angle. Now, the reference angle is important because when we combine our quadrant work with our trigonometry, we are going to be concerned with this angle right here, which is our reference angle. Because it's this angle that's going to be creating the triangles that we're going to be solving on our poorly drawn unit circle. Okay? So we have an angle, we could have an angle there. There's going to be a reference angle here. There's going to be a reference angle here, and a reference angle here. Now in this case, all four of these angles are the same, but they're going to have different, well, this should technically line up here. So let's fix this poorly drawn unit circle. Okay. And this is going to line up with down here. So we have right angle here, right angle here, right angle here, right angle here. Trigonometry, okay? Now, in quadrant 1, say I was to take the sine of this angle theta, well, sine would be equal to my y coordinate. This is an xy. Sine will be equal to my y divided by my radius. And on a unit circle, the radius is always 1, okay? And the radius is always positive. It's always going to be 1. So, in quadrant 1, sine of my angle, my reference angle, is always going to be a positive y over this. So sine of my reference angle in quadrant 1 is always going to be positive y over r, or positive y over 1. And cos of that angle, cos angle r, is always going to be a positive number x divided by my radius, or positive x over 1. Or we can get rid of this over 1, and it's just, we get x is equal to cos of r, and y is equal to sine of r. Okay? So in this, so quadrant 1, my x coordinate is equal to cos of my reference angle, and my y coordinate is equal to my sine of my reference angle. How about in quadrant 2 here? Well, in quadrant 2, now I'm in negative x territory, but I'm still in positive y territory here. So I'm going to have a negative x coordinate and a positive y coordinate over here. So if I was to do sine of theta, sine theta of my reference angle, I would get a positive y over r, or a y over 1, giving me y is equal to sine theta r, which is the same thing as we had over here. And that makes sense, because in both cases I have the same, well, I should be the same magnitude of y, because these both have the same angle, so they should have the same, and they have the same hypotenuse, so they should have the same value of y, which is sine of r, and they're both positive. On the x, however, cos of my reference angle is now going to be a negative x, because we're in the negative territory, divided by my hypotenuse, r, or negative x over 1. So now x is equal to negative cos theta, r, my reference angle. Okay? So that's where that's going to become a negative now. How about down here? Well, down here, I have both a negative y and a negative x. So sine of theta r is going to be negative y over 1, meaning that y, or down here, y will be equal to negative sine theta r, and x is going to be cos of theta r is equal to negative x divided by 1, so x is equal to negative cos of theta r. Just using this. How do we get the negative? Well, if I have sine of theta r is equal to negative y over 1, and I solve, so I get negative y is equal to sine theta r, and then I divide by negative 1, divide by negative 1, that gives me y is equal to negative sine theta r. And then over here, in quadrant 4, I'm going to have a positive value for my x and a negative value for my y. Because I'm in positive, negative. So sine of theta r will be negative y over 1. So sine theta r over here is negative y over r, which is the same as negative y over 1. And then negative y is equal to sine theta r, divide by negative 1, divide by negative 1. I get y is equal to negative sine theta r. So this has to be a negative number because we're in the negative territory. And then x, just looking at it, x is positive, so x is going to be positive cos of my reference angle. So this is why reference angles are important, is they help us once we start doing trigonometry within our unit circle. So what would happen at these points here? Right on my x-axis, y-axis, x-axis, y-axis. Well, up here, my y is going to be equal to my r, and my x is sitting at 0. So this point up here will be x is 0, y is 1. Because my y and my r now are at the same value. Over here, if my r was right here, well now I'm sitting at a value of x is equal to r, so x is 1, and then my y is 0. Down here, my r went all the way down my y-axis, I would have a y is equal to 1, but it's negative. So I have 0 for x, negative 1 for y, because we're in the negative y territory. See how it's opposite? And over here, as you can guess, I'm in negative x territory of 1. My radius is equal to my x. So I'd have negative 1 and 0 coordinate for there. The rest of my coordinates I could calculate using my sine and cosine. And knowing if I'm in my negative cos area or negative sine area, or positive sine, positive cos, negative sine, positive cos. So just knowing where in the quadrant I am will help me a lot. So that's that. And of course, our golden formula here is point xy is point cos theta r sine theta r. But we have to figure out if we're in negative or positive territory for each of those. Thank you for watching.